Alright, so our next components are transistors. These are my favorite. So this is going to lead us down to all kinds of wrong electronics. Fun stuff. Okay? So there's a PNP and an NPN. So because this is a rather lengthy one, I'm going to pre-generate some of the drawing. Okay? So we'll start with the explanation of what a transistor is. So we're going to think of a light switch in your house. Okay? You walk up to the light switch, you go flick, and it turns on the power. Okay? You flicking that, you have some, like, that's your finger turning it on. But what if you can turn it on with other things? Okay? What if you could turn on the lights with the magnetic field of your body? Okay? What if you could turn it on with light? What if you can turn it on with, you could use a button, you could make something so sensitive that if somebody entered the room, it would turn on. Okay? So you can get very, 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 very sensitive things. Like when you chain these two things together in different ways, you can make circuits that just are kind of haunting when it comes down to it, because the level of sensitivity of them will make you question what else is possible. It's the fun stuff. Okay? So the light switch is super sensitive. We'll just say that. It can be triggered in a million different ways. And by triggering it, it's collecting energy and emitting energy. Okay? It can collect the negative and emit the negative. I like using the negative for right now, just for these beginning circuits. And the change of the negative is usually what we trigger it with for right now. Alright, so the 3904 looks like this in schematic form. It's got a base. This is going to be your switch. This is going to be like the thing that gets triggered. This is your collector. This is what's hooked up to your source. And this is what's hooked up to your doodad. Think of it that way. The PNP is the same way. Okay? One is normally on, and one's normally off. So for example, when I touch the light switch, it turns off. Okay? In a different scenario, I touch the light switch and it goes on. Normally on, normally off. Alright. Now, the little dudes have 3 legs. And they're labeled EBC. Again, emitter, base, collector. For this package. So this package looks like this. This is called a package. And there's other ones that look different, and they're not in this order. These are good starter transistors. And this is why I had you buy them. So the package that you got from Elgu only came with a 2222, which is a really good transistor. It goes up to 60 volts and it has a 0.8 amp. So it's really hard to blow this out. There's no doubt about it. It's not that bad. These are a little bit more sensitive. They're faster. So the 3904 and 3906, 1640 volts, 0.2 amps. So they're pretty sensitive. They're easy to blow out. They're pretty fast, but you can chain these together and do really cool stuff. So that's why I had you do this. There's one more I really like. It's called a tip 120, and these things are pretty indestructible. I've done everything from converting DC to AC current, coils, plasma, so plasma arcs, and voltage multipliers using 555s and tip 120s. So they do some pretty amazing things, and they're really hard to blow out. So those are pretty good for new people too. If you're getting into the bigger things, like if you get up to like 12 volts and stuff like that, I would just jump right into the tip 120s, to be honest with you. Alright, so these do a lot more. We're going to do lots of transistor stuff, so I'm just going to go right into a schematic with you, and we're going to have a few schematics with transistors. So this is the very first transistor schematic you're going to have to deal with. So let's go right into the project for transistors. Alright, so let me design this for you. So we got a stoic Xeon, a stoic Cyclops, boom, power source, boom. Okay. So the first thing we're going to do is, like, when you use transistors in a schematic, you should probably like just draw them the furthest away from the power source, because you always run out of room. So I'm going to draw, and we're going to start with the 3904. So we're going to, the only thing that we need to switch with this circuit is this little arrow to make it 3906. Okay, so it's kind of a cool circuit. It shows what transistors can do, and the only thing you have to do is replace the transistor in the circuit. Alright, again, what am I collecting? Okay, what am I collecting? Let's ask yourself that when you're working with transistors. What am I collecting? And I'm going to be collecting negative. What am I going to give it to? I'm going to be giving it to an LED. Do we need a safety? Not yet. Not yet. Not yet. Be kind of cool, but not yet. Alright. So, what about what's triggering it? Well, it's going to be a photocell. And this is going to hook up to the negative. And how do I want to do this so it looks nice? So I'm going to go like this, like this. Yeah. Alright, now here's the key. It's going to need some adjustability. Okay, so we're going to have to take that into consideration and use our potentiometer right off the bat. So I'm going to draw the potentiometer in circuit this time rather than just add it in after the fact. So our potentiometer looks like this. I'm going to move it down just a little bit. Sorry, schematic nerd. So we'll move it down just a little bit right here. Okay, I'm going to attach one side to positive, and I'm going to attach the other to negative. Ooh, that looks good. And then its middle pin is going to go right here. So it's going to connect right there. And if you ever want like connection points look like this. Sometimes you can have those in there. For new people, I always kind of like just hit where things are at. So this is my plus, this is my plus, this is my negative, this is negative, this is negative, Sometimes I'll label these for people. Base, collector, emitter. Those are always nice to have on the schematic. Looks cool, right? Looks like it could take over the world or something. Alright, let's build it. See what it does.